Hello, fellow developers. Today, we embark on a journey into the heart of serverless architecture as we explore the verified CRUD usage of DynamoDB on AWS Lambda. By the end of this video, you'll not only understand the intricacies of seamlessly performing CRUD operations on DynamoDB using Lambda, but also gain insights into the rich history of these two powerhouse AWS services. Let's delve into the world of DynamoDB and Lambda. To understand the present, let's journey into the past. DynamoDB, introduced by Amazon Web Services, emerged as a revolutionary NoSQL, fully managed database service. Its journey began with a focus on providing developers with a scalable and high-performance data storage solution with serverless functions. DynamoDB's architecture, built for responsiveness and efficiency, has made it a go-to choice for applications requiring seamless scalability and low-latency data access. Over the years, DynamoDB has evolved into a fundamental component of cloud-native architectures. Now, let's shift our focus to AWS Lambda. Lambda, born out of the demand for serverless computing, redefined how developers approach building and deploying applications. Its event-driven model, where code is executed in response to events from various sources, introduced a paradigm shift. Lambda enables developers to focus solely on code logic without the burden of managing servers. This serverless architecture has become the backbone of modern application development, allowing for unparalleled scalability and cost-effectiveness. Why do we choose DynamoDB with Lambda? The synergy lies in the seamless integration and complementary features of these two services. DynamoDB's serverless architecture aligns seamlessly with Lambda's event-driven computing model. This pairing offers developers a powerful combination for building efficient and responsive applications. DynamoDB's scalability ensures that as your application grows, so does your data storage capacity. By leveraging these services together, you not only simplify your architecture but also enhance the agility and efficiency of your serverless applications. Now, let's transition from theory to practice with a verified implementation of CRUD operations on DynamoDB using Lambda. We'll start by setting up a Lambda function and creating a DynamoDB table. With each CRUD operation, create, read, update, and delete, we'll dive into the code, providing detailed explanations of every step. This practical guide is designed to ensure that you not only understand the theory behind the operations, but can confidently implement them in your own serverless applications. Let's bring theory into practice with a live demonstration. I've set up a Lambda function ready to interact with the DynamoDB table. Throughout this demonstration, we'll establish connections, perform each CRUD operation, and witness how changes reflect in the DynamoDB dashboard. This hands-on approach ensures that you not only see the operations in action, but also understand the nuances of implementing DynamoDB CRUD operations in real-world scenarios. As we conclude this deep dive into the verified CRUD usage of DynamoDB on AWS Lambda, I hope you now feel confident in incorporating these powerful AWS services into your projects. DynamoDB's scalability and Lambda's serverless architecture create a dynamic duo for building efficient and responsive applications. If you found this tutorial insightful, don't forget to like, subscribe, and share it with your fellow developers. Happy coding, and I'll see you in the next one.